Hi everyone, my name is Calvin. I'm a third-year PhD student working for Kiyo Masui in the CHIME FRB collaboration, and I'm going to report on some FRBs that we're beginning to localize with the CHIME telescope, which I've shown here. As you might know, CHIME is one of the world's premier FRB discovery machines, but has modest angular resolution of just about an arc-minute. To solve this problem and enable the best FRB science, we're planning to build CHIME outriggers, which will do triggered on-demand VLBI on every FRB that CHIME sees. This is challenging, so as a stepping stone, we're developing infrastructure and instrumentation for blind triggered VLBI observations. And we're working just on a short baseline for now with the idea that we will expand to longer baselines. So here you can see the setup we're working with. The CHIME telescope is shown on the left and the Pathfinder is shown on the right. The Pathfinder is a telescope that's operating entirely independently of CHIME using a different backend and a different crystal oscillator clock. CHIME itself is operating an FRB search backend, and as you know, is already detecting many FRBs on its own. We're also beginning to detect FRBs in cross-correlation. So the autocorrelation detection of one of these bursts is shown on the left, and you can see the same burst in cross-correlation on the right. And so the idea is that every time you detect an FRB with CHIME, you will dump voltage data to disk, but you will also send a trigger to the Pathfinder to do the same. And so meanwhile, the Pathfinder is passively buffering raw voltage data, just waiting for a trigger from CHIME. And this way, you can dump a snapshot of the entire sky to disk every time you detect an FRB. How do you do calibration? You can then take that array baseband dump containing the FRB in it for phase referencing as well, because you can phase your array towards the FRB's position and also use the same data to point towards any other position within the common field of view of both telescopes. Shown here are 4 snapshots of the sky. We did that for 2 FRBs and 2 pulsars, and all 4 of these snapshots were triggered observations done entirely blindly. And so you can see the transient that we're trying to localize shown with a cross in each of these snapshots, and also the positions of known steady calibrators on the sky shown in the black dots. And so using this scheme, we can localize these transients to sub-arc-minute precision in 1 dimension on our modest baseline. And this triggered VLBI architecture, we hope, will pave the way towards the science that you can do with a large sample of localized FRBs on long baselines. Thank you very much.